All right, so this problem I had to look outside of the book for the formula. I'm not sure if that was what was necessary, but let's just go over it. Page 54, chapter 2, the programming exercises, we're on number 6. Suppose you have an investment plan where you invest a certain fixed amount every year. Modify FUTVal.py to compute the total accumulation of your investment. The inputs to the program will be the amount to invest each year, the interest rate, and the number of years for the investment. So it's a fixed amount. We're computing the total accumulation of the investment. Amount to invest, the APR, and the number of years. Okay, so we've got the principal, APR in years. Let's use this same one, but which I think is what they're implying. Let's start from the top. What happened here? Okay, there you go. Okay. So with annual deposits. So just reading it again, it seems like it's a fixed amount every year starting from year 1. So that's going to be, and let's assume the formula changes if it's if the deposit's made at the end of the year. So let's make the assumption that where they're made at the beginning of the year. So let's which is also the annual deposit amount. We'll just call it a contribution amount. We don't use the same language. Okay, so the annual rate and the number of years invested. Okay, so all this stuff is going to be the same, but this is going to be the initial principal which will also be the annual contribution amount as well. It's a teeny bit wordy, but I think it's okay. All right, so enter the annual interest rate, year, so that's all going to be the same. So, but our formula is going to be different. Okay, so the new amount, so the formula is going to be different. So I wasn't sure, but I looked around. It looks like this is the best URL to find it currently, which is going to be moneychimp.com/articles/finworks/fmbASINV.htm, and the link's going to be, the link's going to be available. So it's definitely available, so you can look for it. But yeah, so right here, the formula above assumes contributions occur at the start of each year. This is what they're talking about, a basic investment. And so this is going to be the sum of a geometric series, and we'll boil the whole thing down to this. So this is if you have the contributions at the end, this is the formula. But if the contributions are at the beginning of the year, which is going to be here, let's make that clear in our formula, in our comments, with annual deposits at the beginning of each year. Which is also the annual contribution amount at the beginning of each year. That's a lot. It's definitely a lot. I guess we could just split this up into 3 lines. So yeah, let's just make it a little cleaner. Just split it up into 3 lines. And then Let's do this. Come here. And that. Okay, so let's make this 3 lines. Easy to read it also in our program. I would find out what the educator wants to know. Excuse me, what the educator wants to see in terms of, like, do they want you to break up one long line over multiple print statements? You know, you just want to look at, want to see what you know, and maybe even do the assignment early, like a day or two early, and then a couple days early, and then go to office hours and bring your code, and you know, just or bring a list of questions and write the questions down. So let's see. So then here's our principal APR years. Okay, so the formula is definitely not a cakewalk, but it's definitely doable. So this here, so we have this. So you can go Control C on a Mac. We're gonna. I think it's the same with Windows as well. So now we're gonna come here. So this is gonna be a little different because this is with just one initial investment. So this is an ongoing investment. So this is from so it's going to be where P equals principal, Y equals years, C equals annual contributions, and R equals rate. Okay. So we'll do that. And then we can also tighten it a little bit in terms of because it's gonna be a teeny bit tighter. Even though it's tougher to read, I think in this case, because the comment's so long, we want to put it on one line. There we go. So minimum amount. All right. So all right, let's do this. So let's. All right. So it's gonna be. So this is going to be, so our balance is the new amount. Yeah, so this is the balance. So this is the new amount. So we don't even need this anymore. So new amount equals principal. And we could even change this if we wanted to. Change this to principal and APR. But this is you know, if we put this as a quote, then we're showing the educator that we're quoting that exact website. We could even put that in the comments, exactly what the URL is. You know, I can just go like this. And again, it's a lot of it has to do with each educator and whatnot. URL where this formula lies. Okay. All right, so new amount equals principal times, and I think we need a times here, although we don't need it in math class, we do need it for here. So R is going to be our APR, right? And then times is that asterisk, and then Y is going to be years, plus C is going to be annual contributions, principal. Actually, this is going to be contribution. So let's call this annual contribution, just to make it really clear. And then remember PEMDAS from math class. So plus the annual contribution. We can use the same. I think it should work the same way. So then it's going to be like that, and then this is going to be 1 plus APR times years plus 1 minus 1 plus APR slash APR. I think this is pulled correctly from there. The other thing I like to do is what I need to do, not like to do, I need to do, is to count the open brackets and the close brackets. Okay, so we've got 1 and 1, so that should be fine. I think that works the same way, I'm pretty sure. But we'll see. We'll see what the interpreter says. 2 open, 1 closed, 1 closed, 1 closed, and 1 open. I think we need 1 more closed. So 1, 2, 3 open, 1, 2, 3 close. Actually, I think we're good. And then make sure I got the times and stuff here, and that's that. So we got new amount, we got years. Let's see how it works. I think it was okay. I think we're okay on our comments also, because it's sort of new. So I'm going to open this. And we've got val. Nope, that's not it. So I gotta go back. It's right. I'll figure it out. How to do it fast. Okay, so and not make mistakes. All right, so open. Sorry, Python. Value. Okay, this is right because we got a lot of notes. We have the URL. So yeah, we'll see if it runs. Okay, initial principle. So then when we go back to the site, let's just use exactly what site that they use. Oh, it doesn't use any formula. Let's just let's see. So we want to keep, I guess. Yeah. There it is, Money Chimp. Okay. So then we'll go to, let's do 1,000, 0.08, 9. Ah, principal. All right. Oh, I knew I messed it up. I knew I would mess it up. At least to make, one little hiccup. It's, it's rare, I think, at least for me, to just make 0 mistakes. I think it's, it doesn't, it really is humbling though, because it reminds you, like, there's silly mistakes because there's so many of them. Like, it's
And that's why I think practice is just crucial. But what's great about programming also is like this literally tells you what you did wrong. I mean, and you can like copy and paste this stuff to into Google and look it up on Stack Overflow or different sites. I mean, that's what's great about it is you get this immediate feedback loop, that helps you as a programmer, that helps you, and so I like that a lot. All right, so we're gonna go to open. Go here. All right, so did I do it right? Nope, didn't do it right. See, principal. I guess I gotta close the idle again. So let's do a new. Let's do a new file. Let me just try something else. New file doesn't work. Let's do open. I guess if I closed that old one, it would have been good. I'll try that next time. I'll try to close the old one. Maybe that'll work. Yeah, this works. Okay, cool. So what did I do? I mean, I don't. What did I do? Maybe it took a few seconds for it to cycle in, because before I had to like close this whole thing out, or if I X'd out of the old one, I guess I had to X out of the old one. I think I came up with that conclusion like a bunch of videos ago, but then I thought otherwise. I thought, yeah, but okay. So just have to close the other one, and then it opens this one. So then run this. Let's try. So let's try 1,000, 0.08, 9 years. Ah, int object is not subscriptable. Line 23, line 19. Okay, so let's check it out. Remember, coding is debugging. That really is it. If you don't like debugging, go into something else. It's really the joy of like figuring out a problem and trying to solve it. So let's see. So line 23, int. Is it an int? String new amount, string years. Those names are correct. I think that should be fine. But obviously it's not. It's not subscriptable. So my guess is it has to do with the formula. Yeah. Okay. So, which is, I expected a problem with this. Definitely. It's tough. So, okay. So annual contribution times 1 plus APR times years plus annual contribution. So I'm guessing it could be the bracket. Go back to a bracket. Let's see how that works. So you want to think like, or I'm not saying you, but like I want to think like, what might it be? What question mark did I have when I was putting this code in, or when I was looking this up from the website or whatnot? So then let me go here. I'm gonna X out of this. I'm gonna close this, but keep idle open. Oh, I guess it closed. I was trying to close that that specific window without closing the program, but it's all right. Okay. So now we're gonna open. Future value. All right. So let's see how it looks. See what I changed. Yep, I changed it because it doesn't have the bracket anymore. I think that could be it. Possibly. Let's try again. Let's do 0.08. 9. Oh, so it's not callable. Int object is not callable. Okay, so the int object is not callable. Annual contribution. We're evaluating the inputs for annual APR in years. There's the other thing that could be this times. Because, yeah, I think that could be it. And then let's see if, Let's do new file, and then close this one. Let's see if this route works. And then open and future value. Okay. And then we put times here. And then we separate that with times, and then that times. I think we did that. Okay. Yeah, and then that's there. Let's try it. All right, so 1,000.08, 9 years. Ooh, here we go. That's a lot. That's probably a mistake. Is it? I don't know. Maybe. It seems really high. It's got to be too high. It's just got to be too high. So let's do this. It's 1,000. Annual addition is 1,000. Years to grow is 9 years. 0.08. Actually, we're going to do 8% because it's got the percent sign, so we're going to do 8. Start, calculate. Okay, so that makes more sense. 15,000 bucks. So obviously this is a mistake, but it's the same site. So let's see if let's click on this. What was that right there? Okay, so we're going to all right, in the next video, I'm definitely gonna have some of this stuff figured out more clearly, and then I'll show you, my route to get this problem solved. So thank you very much, guys.